Hi everyone, our lesson today from Unit 9 is notes number 5, graphing linear equations. So hopefully much of this will sound familiar from your Algebra 1 class, but this should be a good review. So recall that slope-intercept form of a linear equation is y equals mx plus b. Usually when I ask students to talk about the equation of a line, they can come up with y equals mx plus b. So hopefully you recall that m is the slope, or rate of change, that's the steepness of the line, and b is what we call the y-intercept. And right down below here it says the y-intercept is the point where the line crosses the y-axis. That means that the x value is 0, but you will have a y value. The x-intercept is the point where the line crosses the x-axis. That means you will have an x value, but your y value will be 0. So the first skill you need to have is to be able to identify the slope and the y-intercept for a linear equation. So if it helps, you can write y equals mx plus b right above these. So for part A, the slope is 3, and the y-intercept is negative 1. For B, the slope is negative 1/2, and the y-intercept is positive 4. And for C, the slope is 2/3. And since we don't see anything added on to the end here, you can treat it as plus 0. So the y-intercept is indeed 0. And the next skill we'll take a look at is graphing using the slope and the y-intercept. So just like we did before, we want to identify the slope. The slope of this line is 2/3, and the y-intercept in this case is negative 4. So it helps to draw your x-axis and your y-axis first, and we want to start at your y-intercept. So go to the y-axis and go to where y is equal to negative 4. So that's down 4 from the origin. And then our slope is 2/3, and it's positive, so that means we want to go up 2 units, and then to the right 3. Go up 2, to the right 3, kind of go up the graph at that point, but we only need 2 points to determine our line. In our second example, the slope is negative 1/2, and the y-intercept in this case is positive 2. So come to the y-axis and come up to positive 2 and put a point, and then use your slope of negative 1/2 to graph a few other points to make your line. So from the y-intercept, we want to go down 1 up to negative 1, but then go to the right 2, down 1 to the right 2, and then connect your points. Now we could have also have gone up 1 and to the left 2, and that would have been another point on our line. Okay, lines with a positive slope rise to the right, while lines with a negative slope fall to the right. So when you read your line from left to right, if it's increasing, it has a positive slope. If it's decreasing, it has a negative slope. Another form for writing equations is standard form. We have ax plus by equals c. And there are a bunch of rules around standard form. But the easiest way to graph an equation in standard form is to find the x-intercept and y-intercept and then graph them, because we only need 2 points to determine a line. Okay, so for the first example, it says graph the line 2x plus 4y equals 8. So if we want to find the x-intercept, well, first let me draw the axes on this graph. So we want the x-intercept. We really want to know where y is equal to 0. So what we do to find that x-intercept, we substitute in 0 for y and solve for x. Because remember, we want to figure out x comma 0. So we do 2x, follow the rules, substitute 0 in for y, and that's going to give us 2x plus 0 equal to 8, or 2x equals 8. And what we're doing now is solving for x. And if we divide by 2, we get x equals 4. So that means that our x-intercept is at 4, 0. So let's put that in blue. So go to the right 4, up 0. That's our first point. To find the y-intercept, we do the opposite. We put 0 in for the x and solve for y. So substitute 0 in for x. We get 2 times 0 plus 4y equals 8. That's 0 plus 4y equals 8, or 4y equals 8. And that is going to give us y equals 2. So this time around we have the point 0, 2. So if you connect those 2 points, that's the graph of your linear equation. Finally, we'll take a look at horizontal and vertical lines. A horizontal line is a line like this blue one. And you see this blue line has a slope of 0. But what we notice is that each point on this blue line has the same y value. For example, this point right here is at 1, 3. This point is at 2, 3. This point is at 3, 3. I think you get the picture. This point is at negative 1, 3. This point is at negative 3, 3. So it doesn't matter what x is equal to. For this particular line, y is always equal to 3. So when you write the equation of a horizontal line, it's always going to be y equals a number. Okay, so for example, if I draw another blue line, let's say down here, you want to look at the y value of any point on that line. So the y value of this point right here would be negative 4, because this point has coordinates 0, negative 4. This point would be 3, negative 4. So this line at the bottom of the graph has the equation y equals negative 4. Okay. For vertical lines, something different is happening. Now we have a slope that's undefined. So we would really be stuck if we wanted to use slope-intercept form for this equation. We can't actually. In this case, you want to take a look at the x value of each point on this line. So for this first red line that I drew, this point is 1, 0. This point is 1, 1. This point is 1, 2. This point is 1, 3. Now you notice what's staying constant here is that the x value is always 1. So for the equation of a vertical line, it's always going to be x equals a number, whatever the x value is in all of your points. So x equals 1 is the equation of that first line that I drew. If I came over here to where x is equal to negative 2, this would be negative 2, 0, negative 2, 1, negative 2, 2, and so on. The equation for that vertical line would be x equals negative 2. So if we want the equation of a horizontal line, it's going to be y equals a number. If you want the equation of a vertical line, it's going to be x equals a number.